In this video, let's begin by taking a look at performing a compression test on the internal combustion engine while it is removed from the vehicle for inspection. With the motor starter battery to rotate and crank the engine. This is the motor. This is not the motor, and this is not the engine. Let's begin our compression test.
Before removal of the spark plug, we want to make sure we apply some power lube down on its threads so it does not strip the aluminum inside the cylinder head.
In the video description, there is a video link revealing how to read spark plug for performance or malfunction. The engine before us here is the 2001 Nissan VQ35DE from the El Grande.
Okay, now when we take a look at that spark plug, we can see we have some solvent because the tip is wet. That's from the oil that we pour into the cylinder to help emulsify the piston ring against the piston. So this is the spark plug that was removed 100,000 miles from the VQ35DE engine. When we look at these two spark plugs, they basically look the same. And what I'm talking about is the center electrode. That's the part that comes out of the center. You can see how it has a lot of wear and tear from burning the fuel. So right away we know this engine is almost 100,000 or over 100,000 miles based on the spark plug inspection. Inspection of the spark plug will reveal all information about how the cylinder is operating, whether it is losing power, overpower, or some foreign contaminant is leaking into that cylinder. So spark plug inspection is the most important part in a engine inspection, but we must still inspect the mechanical moving parts of the engine by cranking this engine outside of the vehicle for compression and no hammer knocking. When removing the spark plug, you always want to make sure you're using a spark plug socket, because in this socket has a rubber boot that holds the spark plug into the socket for easy removal. Here again, when we take a look at this spark plug, we can see the center electrode is most likely obliterated or excessive use. And that is our last one for the left side. All of them is basically identical, which is a good sign. This means that the cylinder is not malfunctioning outside of the others. When we take a look at both of these NGK spark plugs, we will see their part number. This is the part number for the VG33E, and the part number for the VQ35DE is PLFR5A. So that 5 is basically a heat range for the spark plug. See also there's a 5 there. So that's a middle range for the heat range of the spark plug. If that number was 9, it would be hotter. If it was 1, it will be colder. Let's take a look at the right side. Now when we take a close look at the right side, you can see a difference in the appearance from the right side to the left side. So that appearance is basically, we have basically cleaned inside here, removing all the oil stain, sending it down to the crankcase. Later on, we will remove the drain plug from the oil pan and drain all this stuff that was cleaned up here, which will now be down in the oil pan. Very important that the valve train is maintained clean and sludge free. So it is very important that the valve train remains sludge free and clean. So this spark plug is the same thing. You see, when the sludge build up in here, if this engine had an EGR valve, there will be more sludge in this area. And as that sludge build up and develop under this valve cover, there are holes at the bottom part of the cylinder head so the oil can return to the oil pan. The development of sludge and carbon under the cylinder head will block those return holes, preventing the oil from returning to the oil pan. That oil will then build up in this cylinder head under this valve cover and start acting on the gasket, causing it to leak. So it is always best to perform an engine oil flush every time the oil is being changed or serviced. What this engine oil flush will do is that it will clean inside the engine crankcase, removing all the sludge down into the oil pan. Failure to clean the sludge out of the engine will destroy the engine because of poor lubrication. So since this engine does not have an EGR valve, it means that the engineer was a professional at tuning the air-fuel ratio so the engine does not pollute. When an engine is equipped with an EGR valve, it means that the engineer is having issue tuning the air-fuel ratio to pass EPA gas law. By installing the EGR valve, that keeps the combustion chamber cool and prevent the engine from making pollution or contaminated gas. Very, very important that emission is understand when repairing an engine, because the emission is what keeps the engine alive and prevent pollution. With all the spark plug removed, it's time for us to install our compression gauge tool to check the compression of the cylinders. Now that all the spark plug is removed, the engine will be most easy to crank, creating less stress on the starter and the battery. This is the best way for performing a compression test, by removing all the spark plugs. Removing the spark plug will also allow the engine to spin much faster for recording of an accurate compression pressure test. Cleaning under the valve cover for the cylinder head, we're going to use this power degreaser, also known as power blaster or the purple blaster. Just want to apply a light coat of this degreaser. This will emulsify the grease on the surface, returning it to the oil pan. Now we'll let this soak for a little bit and then we can wash it away. Once evidence is shown that the degreaser is emulsifying this sludge, then we're going to take some water, simply spray this surface down, washing all this sludge down into the oil pan. So we have to be careful here because we have a lot of stainless steel metal which will most likely become corrosive, and those metal are the camshaft, the valve tappet, the hydraulic tappet. These things cannot become corrosive or show sign of surface rust. Once the cleaning has been complete, all these puddle of liquid will need to be saturated with some form of paper towel or cloth to remove the water from the metal, the iron, so it does not become rust. So we'll basically just take a rag and saturate this. Also, shop air will be perfect for blowing this out of the way. Also take notice that the inside of the cylinder head, aluminum color after cleaning, is more different than the outside of the engine. So the oil has preserved the surface of the aluminum inside of the cylinder head, retaining its new factory look. So this is basically the best judgment for telling that this engine has aged for approximately 17 years and could never have 35 or 30,000 miles. Take notice how the purple cleaner has oxidized the surface of the aluminum on the outside of the engine when compared to its internal, which has been preserved by the lubricating oil. It's time to remove the oil filter, and as we can see, it's a Asian Chinese writing on the oil filter, which tells us that this engine came from Japan. So here's a tool that you might want to purchase for removing that oil filter, but it's not recommended because this is the smallest the wrench will get to for removing this oil filter. So you might need something a little smaller, but we were able to use this one for removing this oil filter. So when you're going to take this out, oil is going to pour out of here. Always, if there's no oil in here, then there's a problem with the oil pump, most definitely. So once we get this out of here, we have to replace this with a new oil filter. Then we could install this 2050 weight oil, since the vehicle will be operated in desert condition, approximately 100 degrees in Fahrenheit. Alright, so here we'll notice the filter is a high performance oil filter. So this tells us that the owner of this vehicle engine was into what we expected, maintaining a high performance standard. So the engine could last beyond 100,000 miles. This is a very good sign that this engine might be in top fit condition. Okay, at this point, this is not a safe position to have the engine. So it's always best to mount the engine like this onto a engine stand for draining the oil sump and rotating the crankshaft flex plate during compression tests. If the engine is not in its vehicle compartment. But once the vehicle is in the engine compartment, you're going to want to replace that oil filter with a Purolator oil filter. This is one of the best oil filter on the market. So before it can be installed, it must be filled with oil until it saturates that filter element. Then the O-ring seal can be swiped with a light amount of oil before installation for the oil filter. The oil filter will most likely have to be installed by hand, twisting it till it becomes tight, because using the tool will most likely damage its casing. Using of the oil filter pliers will require grabbing the oil filter at its upper rim and not the body, because the claw will most likely damage or puncture that part of the oil filter. Take notice how the new Purolator oil filter is much longer than the one we removed. This is more filtration for the oil. Here is two excellent products for using before changing the engine oil. This is a motor flush. This is an engine flush. Basically the same thing. The words are just confused. Now we want to add petroleum oil to the engine. This engine requires, somewhere I saw in the literature, approximately 10 quarts of oil, and that oil I believe is required to be changed at every 10,000 miles. Well, we're going to start with a 5 quarts of oil to see if the oil pump is functioning by producing oil pressure up into the valve trim.
A 2050 weight conventional petroleum oil is highly recommended for any engine that is over 100,000 miles operating in extremely hot conditions. If the weather should adjust to a cold weather climate, the oil will also have to be adjusted and change its grade to approximately a 1030 or 530 weight oil. Also consider today's engine operating at approximately 200 to 220 degrees Fahrenheit. The 2050 weight grade oil will remain most protective against wear and tear at high temperature. If the engine coolant temperature thermostat is to be changed by lowering its temperature, the engine oil will require a lower grade.
With 5 quarts of oil added to the engine crankcase, we will now check the dipstick for its level. So here we can see the engine will still require more oil since it's indicating on the low side of its dipstick. The engine will be filled with the remaining oil once it's ready to start up at the completion of the conversion swap.
At this point, adding a conventional petroleum oil is most important for this type of engine. The most highly recommended oil for these type of engine will be a synthetic oil, which is a sand oil or a charcoal oil. It's oil that originates from charcoal or sand, and petroleum oil is basically from crude oil. So what happens is when you use synthetic oil inside this engine, even if it does not have an EGR valve, the combustion gas which deposits carbon into the oil will basically absorb the synthetic oil, and that will reduce the oil ability to lubricate and maintaining a sump level. Using of the conventional petroleum oil, avoid all the negative from the synthetic oil. At first, synthetic oil will perform great. As the engine endures, that oil will lose its performance due to carbon buildup. This is not the case with conventional petroleum oil. So using a conventional petroleum oil is the most important thing you could do for an engine, for it to endure for a lifetime.
In most cases, you will want to pour the lubricating oil onto the valve trim so it can be pre-lubed during cranking and startup. Notice the oil that puddles below on the cylinder head. This is what we will look for on the right side cylinder head during cranking of the engine. It is most important that the engine is always lubricated during its rotation process. The engine oil is the lifeblood of the engine. The engine oil cools and lubricates the engine.
Before cranking the engine to verify oil pressure is available, it is always best to add a few caps of engine oil to the spark plug hole inside the cylinder to lubricate the piston ring against the cylinder.
Since the engine will be located in the vehicle during this process for most of the people who will be performing this procedure, it is always best to remove the fuse for the fuel pump and the ignition spark plug system.
Securing the engine to a stable structure is most important before cranking compression tests.
It is now time for us to crank this engine outside of the vehicle and witness that oil flows up into the camshaft and the valve tappet. Synthetic oil do have their purpose and service in the industry, and that will be for transmission fluid, power steering fluid, or gear oil. Synthetic oil is not really a good lubricant for the internal combustion engine when compared to conventional petroleum oil. Removal of the compression tester tool is most important for cranking the engine to gain speed for the oil pump to generate that oil up into the valve train. This will be the best time to remove the duct tape from the intake port and all its paper towel. Also from the exhaust port on the right and left side will require removal before cranking of the engine. With the car battery connected by heavy-duty jumper cable to the engine starter, it is now time for us to crank the engine. But before doing so, we want to make sure we remove the air condition compressor belt and the alternator power steering belt, freeing up the crankshaft from excessive work that may reduce the lifespan of the battery. Let's continue and look for oil pressure to flow up under the valve cover, twin cam. Since no oil pressure appears, let's check the compression pressure for cylinder number 1. Okay, so that is approximately 190 psi. Okay, let's check cylinder number 3. Okay, so that's approximately 190. Okay, let me show you what happened to the tool. So we did not get an accurate reading because a piece of the tool remained inside of this cylinder. See, these are all things that has to be checked. Alright, the best way to get this out, you wouldn't believe it, I had to use this knife and stick it down in there, so you don't want to make this mistake and install this part of the compression tester tool. I'm going to use this part with the O-ring. Let's do another test and see if we will receive oil pressure. Okay, so this is a little better. This is approximately 190, almost 195. Just want to put some lube on these cam until we could receive oil pressure from the oil pump. Very important that we have some form of lubrication. Okay, so this we have the same thing. It's approximately 190, 195. Let's check cylinder number 5. Okay, so this we have almost 195, just below 210. So actually no, this is 205. Just below 210, so the others will be approximately 200. This will be 200, this will be 200, while this, so we're getting some drop off. Still, we do not have any oil pressure or oil showing on the cylinder head. So we will move to the other side and do the same test and check again to see if oil rise in these areas. Let's start with the left side cylinder bank, cylinder number 2. So here we can see we have approximately 200, and that will be about 230, and it's dropping. So here again we can see this went almost to 240. So this all has an effect to do with the oil sealing with the piston ring, since we pour oil down into the cylinders. Let's try cylinder number 6. Okay, so this one is a little low. Let's try this again. This is complete the test for compression on all the cylinders, and as we can see, we have a slight verification and difference on the right side to the left side cylinder. Once the engine is installed and started, we will perform another test to verify that all the cylinder compression pressure is equal, for it is unfair to make that assumption right now, since the piston rings are not lubricated by the proper RPM of the engine. Let's check the other side to see if oil developed in the cylinder head. So here we can see there is no oil that's puddling from the oil pump, bringing the oil up to the cylinder head. Let's try one more time. Okay, so this will have to be verified once the engine is in the vehicle. This has basically complete our inspection of this engine, and based on its result, it appeared to be a properly working engine. With no oil rising to the upper valve train, it is time to remove this oil pressure sensor with the adjustable pliers. Once this pressure sensor is removed, we'll be able to verify if oil flowed from this port. So here we can notice there's no oil flowing from the port, which is a sign that the oil pump is not producing oil pressure to the sensor. This engine can be fitted with a turbocharger, which will most likely be bolted in this area. So to lubricate that charger, you will need to tap in to this oil galley, or where the oil pressure sensor is located. Also, on the front of the engine next to the water pump, you will notice another 12mm stud. That is for coolant bypass to the turbo, for cooling that turbo center section. Since the oil pressure sensor failed to receive oil pressure, that will be an indication of no oil flow in the upper valve train. So let's take a look at how this starter is mounted with the transmission bolt and a socket threaded to the saddle of the starter, while at the top we use a conventional nut and bolt for holding the starter fixed in the engine block. But you will notice that the drive pinion gear for the starter is hung up onto the flex plate. This is because the starter return spring for the armature to the solenoid is most likely broken or weak. Releasing of the starter shackle bolt is still unable to free the starter drive pinion gear from the engine flex plate. This is a sign that the return spring for the drive pinion gear for the starter has become weak or broken, causing its pinion gear to hang up on the engine flex plate. During the process of starting the engine, if this should happen, the engine will create a loud noise from the dragging condition of the flex plate onto the starter pinion gear currently in position. To try and remedy the situation with this starter pinion gear and the flex plate, we will use a screwdriver for prying it off of the flex plate. At the same time, we want to place some lubricant on the teeth or the tooth of the flex plate and the pinion gear. This should be done in a complete circle. This oil will allow the gear to in-sync itself while it's rotating and maybe provide easy releasing. So like we have figured, it did not release. That's because the spring inside the starter is most likely broken or lost the force to release the pinion gear from the flex plate. If the malfunction of the starter pinion gear is still hung up on the flex plate during starting the vehicle, once the engine is started, the engine speed will increase and continue to rotate the starter, making a annoying noise. The simplest thing to do is to shut the vehicle off and release the pinion gear from the flex plate. So since we have added approximately 5 quarts of engine oil to the oil pan sump, that oil will most likely be somewhere down here, unable to gain suction by the oil pump strainer, which might be a little above its current level. We will now add another 5 quarts of oil, which the engine is required 10 quarts. Cranking the engine, we will look for oil pressure at the oil pressure sensor and the upper valve trim. Finally, 7 quarts of oil was added to the engine to verify that oil pressure presents itself under the valve. With no oil pressure, we will now remove the oil pressure sensor switch to verify oil in the oil galley. Okay, so this is a bad sign. This is basically telling us that this oil pump is not receiving any oil from the sump. Could be it's cavitating, requiring the engine to start for higher RPM to prime the pump to produce oil pressure. So this is something we might have to look out for when the engine is installed into the vehicle. With the twin cam cover removed from the engine, now will be the best time to basically detail it with some paint. The reason this needs to be done is because the aluminum surface has become so aged that the iodized shine from it has disappeared, and this will cause the aluminum to oxidize. Applying the paint is the best way for protecting the exterior of the aluminum twin cam cover from oxidation. Before painting these twin cam cover, we always want to make sure that we're going to be doing this type of spray painting on a table, preferably hanging the covers from a hanger so airborne dust does not become in contact with the surface of the paint when it is applied. Before the surface can be painted, it is always best and most important that it is cleaned with some form of high quality paint thinner like this acetone from the Rust-Oleum company. And we are also going to use this engine enamel 500 degree Fahrenheit engine paint. Since these valve covers are going to be painted on the ground, it is always best to fan the area away any dust that may become in contact during the process of painting. Like always, it is never best for doing this type of painting on the ground since the ground is highly contaminated with dust. Also, applying water to the ground is the best way for suppressing dust that may become airborne. Okay, so this is what we want to be looking at once finished painting. Unfortunately, if you're using this product and this spray can, you're going to get a lot of those drips. That is something that's inherent with the can. Paint and the nozzle doesn't go together, but since this is the remaining paint from the rim that we have prepared in the same manner, we're reusing the leftovers. So in video description you will see a video on how to paint aluminum parts or rim before they become a disaster. With that little drip right there, I just want to overspray it to basically hide it. So it's good luck with this product. That's all I could say. Now, leaving the product in the sun to dry will be the best thing since it's a high temperature paint. With the paint dry and the masking tape removed from the oil filler neck, we must remember to install this O-ring for sealing the paint with its oil filler neck and two 10mm bolts, not forgetting the O-ring oil seal